There was a year, almost 1500 years ago, when the sun gave no warmth for 18 months. Crops failed across 3 continents. Half the people you would have known were dead within 10 years, and nobody at the time knew why. That was one of 10 moments when the human story came within a generation of ending. Some left mass graves we can still excavate. Some left chemical fingerprints in the ice at both poles. One left so few survivors that every person alive today carries the genetic scar. We are going to walk through them in reverse, from the least catastrophic to the worst. 10 times civilization almost did not make it. 1859. A solar storm hit Earth so violently that telegraph wires caught fire on 2 continents. On the 1st of September 1859, an English astronomer named Richard Carrington was sketching sunspots through a small telescope when one of them brightened white-hot in seconds. He had just witnessed the largest solar flare ever recorded. 17 hours later, the storm reached Earth. Auroras lit up skies as far south as Cuba, Hawaii, and the Bahamas. In Colorado, gold miners woke at 1 in the morning and started cooking breakfast, convinced it was dawn. Telegraph operators across the United States and Europe reported sparks leaping from their keys. Some unplugged their batteries and discovered the wires were carrying enough current, pulled directly from the geomagnetic storm overhead, to keep transmitting on their own. Others were burned at their desks. Paper records caught fire. The storm raged for nearly 3 days. Compass needles spun freely. This was the first time a solar superstorm had ever hit a planet that depended on electrical infrastructure. The world barely had any infrastructure to lose. A few thousand kilometers of telegraph wire burned out. A few stations were destroyed. Within a week, the network was patched and forgotten. The number that matters is what happens if the same storm hits today. A modern Carrington-class event would induce massive currents in continent-sized power grids, the long, high-voltage lines that move electricity across countries. Those currents would melt high-voltage transformers across North America, Europe, and East Asia. Replacement transformers take between 18 and 24 months to manufacture. There is no global stockpile. A Lloyd's of London study estimated damages between $600 billion and $2.5 trillion, with a recovery period measured in years. Hundreds of millions of people without electricity. No water pumps, no refrigeration, no internet, no payment systems. The collapse would be quiet and almost total. We know the 1859 storm happened because Carrington wrote it down. We know the magnitude because it left a chemical fingerprint, a nitrate spike, in Greenland and Antarctic ice cores. We can compare it to weaker storms in the modern record, like the 1989 geomagnetic storm that killed the entire Quebec power grid in 90 seconds. The Carrington Event was several times stronger than that. NASA and NOAA estimate the chance of a Carrington-class storm hitting Earth in any given decade at around 12%. In 2012, a storm of similar magnitude crossed Earth's orbit and missed. Earth had moved on. We were lucky by 9 days. The next event of that magnitude is not a probability question anymore. It is a question of when. And in 1859, the consequences were 40,000 miles of damaged wire. Now, they would be everything we plug in. That was the smallest item on the list. The next one came with a body count. The year 165. A Roman army returned from the eastern frontier, carrying a disease the Mediterranean had never seen. And within 15 years, it killed roughly 1 in 10 people in the empire. It started in Mesopotamia. The emperor, Lucius Verus, was campaigning against the Parthian Empire. His army sacked the city of Seleucia and brought home a strange new fever. By the time the legions reached Rome, soldiers were dying along the road. The fever followed them west, into Italy, into Gaul, into Egypt, into Britain.
A Greek physician named Galen, court doctor to the emperor Marcus Aurelius, watched the disease arrive in Rome and described its symptoms in clinical detail. High fever, black pustules over the body, drying to scabs that fell off as the patient recovered, or did not. Diarrhea, bloody coughing. He survived it himself. Most of his patients did not. Modern researchers, working from his descriptions and from later genetic studies of related viruses, believe the Antonine Plague was an early form of smallpox, variola major, encountering a Roman population that had never been exposed and had no immunity. Estimates of the death toll vary. Conservative numbers put the total at 5 million. Some historians, working from tax rolls and military recruitment records, push it closer to 10 million, about 10% of the empire. 2 emperors are believed to have died of it: Lucius Verus in 169, Marcus Aurelius himself, possibly, in 180. The damage was not only the dead, the legions were gutted. Frontiers that the empire had held for 2 centuries went thin. Tax revenues collapsed because the people who paid taxes were gone. Trade routes broke down. Whole towns were abandoned. Historians today read the Antonine Plague as the first crack in the Roman Empire's foundation. Not the cause of the eventual fall, that is 3 centuries away, but the moment when the curve of Roman power, which had only ever bent upward, started to bend the other way. The modern parallel is direct. The Antonine Plague is the prototype of every pandemic that follows. A pathogen evolves in one population, encounters another that has never seen it, and travels along the connecting infrastructure. For Rome, that infrastructure was the legions and the trade roads. For us, it is the airlines. The reason a global pandemic in the 21st century is a question of timing rather than possibility is that we have not removed the mechanism. We have only made it faster. The next item on the list took less than 2 days, and it was loud enough to be heard halfway around the planet. August 27, 1883. A small island in the Sunda Strait detonated with the loudest sound recorded in human history. The island was called Krakatoa, sitting between Java and Sumatra on the most active volcanic arc on Earth. It had been showing minor activity for months. Tourists were taking sightseeing boats to watch the steam plumes. Then, on the 26th, the eruption began in earnest. Plumes of ash reached 25 kilometers high. By the morning of the 27th, the volcano was tearing itself apart. There were 4 major explosions. The third one is the one written into the seismic record forever. It was heard 4,800 kilometers away, in Perth, Australia, and on Rodriguez Island in the Indian Ocean. Sailors 3,000 kilometers off in the open ocean reported their eardrums rupturing. The atmospheric shockwave circled the planet 7 times. Barographs in Europe, instruments measuring atmospheric pressure, registered the same wave passing overhead day after day for almost 5 days. 2/3 of Krakatoa Island vanished into the sea. The ocean's response was a tsunami. A wall of water between 30 and 40 meters high tore through the surrounding coastlines. It destroyed 165 villages on Java and Sumatra. Around 36,000 people died, most of them not from the eruption itself, but from the wave. Bodies were carried hundreds of kilometers and washed ashore in the weeks that followed. A Dutch warship called the Burro was carried 2.5 kilometers up the Keripan River and deposited in the jungle. Its crew of 28 did not survive. Krakatoa was the first global natural disaster reported in real time. The newly built telegraph network sent the news around the world within hours, the first time any catastrophe had been transmitted that fast. For more than a year afterward, sunsets over London, Paris, and New York burned bright red. The painter Edvard Munch, walking outside one Norwegian evening, later said the sky looked like blood, the inspiration, possibly, for for the scream. The 1884 growing season was unusually cold across much of the northern hemisphere. Average global temperatures dropped by several tenths of a degree Celsius. The cooling lingered for years. Harvests came in late and short. Prices climbed, and 10,000 kilometers from the volcano, peasants in northern Europe suffered cold and food shortages. They had never heard of Krakatoa. Krakatoa registered a 6 on the Volcanic Explosivity Index. The scale only goes to 8. A 6 is enormous, but the volcanoes higher on this list are an order of magnitude more violent, and there is one waiting in the same place. The vanished island left a daughter cone behind, slowly rebuilding from the seafloor. It is called Anak Krakatoa, the child of Krakatoa. Before its 2018 collapse, it stood roughly 330 meters above the water. That collapse triggered another tsunami that killed 430 people. The cone is rebuilding now. The volcano is not finished. The next event on this list did not come from a single volcano or a single fever. It was the moment a dozen civilizations died at the same time. Around the year 1200 BC, every major civilization in the Eastern Mediterranean burned to the ground within 50 years. It was the most successful, most connected world the planet had ever produced. Egypt was at its height. The Hittite Empire ruled most of modern Turkey. Mycenaean Greece built the cities later remembered in Homer. Babylon, Assyria, the kingdoms of Canaan and Cyprus, the great trading port of Ugarit on the Syrian coast. All of them traded with each other, fought each other, and depended on each other for tin and copper to make bronze, the metal their entire technology was built around. Within 50 years, almost every one of them was gone. Hattusa, the Hittite capital, was burned and never reoccupied. Ugarit was destroyed in a single night. The last clay tablets from its archive, letters never sent, describe ships approaching from the sea. They never finished writing. Mycenae burned. Pylos burned. Knossos burned. Egypt was attacked twice in a single generation and survived only barely. Linear B writing, the script of the Mycenaean palaces, was simply lost. Greece would not write again for 400 years. On the walls of his mortuary temple at Medinet Habu, the pharaoh Ramesses III had his scribes carve the story of the invasion in stone. Fleets of longships approaching from the islands, helmeted warriors fighting Egyptian troops in the Nile Delta, the survivors driven into the sea. He named the attackers simply the Sea Peoples. Where they came from, who they were, why they appeared all at once, none of it is known with certainty. But invasion alone does not explain a collapse this total. There has to be something underneath. In the last 20 years, climate scientists have found it. Pollen records from the Sea of Galilee, oxygen isotope data from cave stalagmites in Israel and Cyprus, and dendrochronology from the Eastern Mediterranean all show the same signal. A megadrought, 2 centuries long, beginning around 1250 BC and bottoming out at 1200. Rainfall in the Eastern Mediterranean dropped by 30 to 50%. Crops failed. Granaries emptied. The trade networks that had moved grain from Egypt to Anatolia broke down. A hungry, weakened, interdependent system met an external shock. The shock could be sea peoples, internal revolt, earthquakes. Different scholars emphasize different triggers. What they agree on is that no single one of these things could have done it. The system was already fragile. Anything could have pushed it. When it fell hard. Population in Greece dropped by an estimated 75%. Cities were not rebuilt for centuries. The technologies of bronze working, monumental architecture, palace administration, and writing all vanished from large parts of the Mediterranean for hundreds of years. Historians call the period that follows the Greek Dark Age. The Bronze Age collapse is the first historical example of what is now called a systems collapse, the simultaneous failure of an interdependent network of states under combined climatic and economic stress. Modern political scientists who study civilizational risk treat it as the prototype. The reason it matters now is that the world we live in is more interconnected than the Bronze Age was by orders of magnitude. The same logic applies. A long, slow stress event that no individual state can solve, layered onto a system that depends on every part working. That is how civilizations end. The next time it nearly happened, the cause was a single year of darkness. The year 536. The sun gave no warmth and no shadow for 18 months. A medieval historian called it the worst year in human history. The historian was Procopius, a Byzantine writing in the court of the Emperor Justinian. He recorded what he saw with the careful, almost confused language of someone who knew the words for what was happening: eclipse, fog, dust, and knew none of them quite fit. The sun, he wrote, gave its light without brightness, like the moon, during this whole year. Crops did not ripen, fruit did not form. Snow fell in August in Mesopotamia. Frost killed harvests in Italy. He was not exaggerating. 3 other independent sources from China, Ireland, and the Mediterranean recorded the same year. A dry fog covered the sky. The sun was visible but dim. The temperature dropped sharply across the northern hemisphere. Modern ice core records confirm what the chroniclers wrote. There is a massive volcanic sulfate spike in Greenland and in Antarctica dated to 536. There is a second one in 540. 2 enormous eruptions in less than a decade. The first probably from Iceland, the second from a tropical volcano in the equatorial region. The exact source still unidentified. Together, they injected enough sulfur into the stratosphere to dim the planet for years. Tree ring records from Europe, Siberia, and North America show that 536 to 545 was the coldest decade in the last 2,000 years. Colder than the height of the Little Ice Age, colder than the year after Krakatoa. Crops failed across 3 continents. Famine became chronic. The Eastern Roman Empire, only just beginning to recover the territories of the western half, lost its ability to feed its cities. And then, in 541, the plague arrived. It came up from Egypt and spread along the Mediterranean trade routes, the same Yersinia pestis that would return 8 centuries later as the Black Death. This first wave is called the Plague of Justinian. It killed an estimated 25 to 50 million people across the empire and beyond. In Constantinople, at its peak, contemporaries described 5,000 bodies a day being dumped into open trenches. It was the same pattern the Antonine Plague had used 4 centuries earlier. A connected world, a weakened population, a new pathogen. The harvest failures of the volcanic winter had set the stage. The plague filled it. In 2018, the historian Mike McCormick of Harvard called 536 the worst year to be alive in human history. Not because of one disaster, because of the cascade. Volcano, then plague, then collapse, all stacked on top of each other in a single decade. The modern parallel is harder to dismiss than the others. There are at least 20 volcanoes on the planet today capable of producing 536 class eruptions. The probability of one going off in the next century is, by any reasonable estimate, somewhere between 30 and 70%. We have no plan for it. There is no insurance program for 2 consecutive years of failed harvests across the entire northern hemisphere. The next item on the list is what happens when that kind of failure happens to a population that is already running on empty. October 1347. 12 Genoese trading ships docked at Messina, Sicily. Most of the sailors aboard were already dead or close to it. Within 5 years, Between 30 and 60% of Europe was dead with them. The disease was Yersinia pestis, bubonic plague, and it came from the steppes of Central Asia. It had been moving westward along the Silk Road for years, riding in the fleas that lived on the rats that lived in the grain bags of every caravan and ship. By 1346, it reached the Crimean port of Kaffa, where Genoese merchants had a trading post. The Mongol army besieging the city was hit first. Some accounts claim the besiegers catapulted the bodies of plague dead over the city walls. The story is disputed. The result is not. The Genoese fled, and they brought the disease with them. From Sicily it went to Genoa, to Marseille, to Venice, to Aleppo. By 1348, it was in Paris and London. By 1349, it was in Norway. The infrastructure of the medieval world, every road, every shipping lane, every pilgrim route, became a vector. The mortality is staggering even now. Norwegian historians estimate 60% of their country died. England lost between 40 and 50%. Florence fell from 120,000 to 50,000 in a year. Globally, the death toll is estimated at 75 to 200 million people. It was the largest mortality event in human history by absolute numbers, and one of the largest by percentage. We know the cause now because we have read its DNA. In 2011, researchers extracted Yersinia pestis genetic material from the dental pulp of skeletons in a London plague pit at East Smithfield. The strain was sequenced. It is the direct ancestor of many of the Yersinia pestis lineages alive today. The disease did not end in the 14th century. It just went quiet. There are still around 2,000 cases of human plague reported globally each year, mostly in Madagascar, the western United States, and Mongolia. It is treatable with antibiotics when caught early, but there are documented multi-drug-resistant strains, and Yersinia pestis is widely studied as a potential biological weapon. The reservoir species, the rodents that carry it in the wild, exist across Africa, Asia, and the Americas. The Black Death rewrote European society. Wages for surviving peasants tripled within a generation. Feudalism, which depended on cheap and abundant labor, broke. Entire villages were abandoned, never resettled. Religious authority was shaken. A generation of children grew up watching priests die at the same rate as the people they buried. Some historians argue the demographic shock that hit Europe in the 14th century is one of the preconditions of the Renaissance. The reason this event ranks as low as 5th and not 1st is that humanity, on the global level, came out of it. Europe survived. Asia survived. The plague was not extinction level. But the system that allowed it to spread in 3 years across an entire continent has only become tighter since. The plague needed Genoese galleys to cross the Mediterranean. It needed weeks. The next pathogen of similar virulence will have airplanes. The next item on this list takes us back to a volcano, a bigger one, the one that bent the entire climate of the late medieval world. 1257. The largest volcanic eruption of the last 700 years happened on a small Indonesian island, and for 7 centuries, nobody could find the volcano. The evidence was everywhere. Greenland and Antarctic ice cores both contain the largest volcanic sulfate spike of the last 2,000 years, dated to the late 1250s. Tree rings from California to Mongolia show that the summers of 1258 and 1259 were among the coldest in the entire Common Era. Medieval chroniclers across Europe described a strange, dry fog that dimmed the sun. 2 total lunar eclipses in 1258, in May and in November, appeared completely black to chroniclers in England and Italy, the moon invisible in Earth's shadow. That is what a heavy stratospheric sulfate veil looks like from the ground. In London, a single mass burial ground at Spitalfields held the bones of thousands, dumped quickly, all together,
in the years around 1258. Archaeologists initially thought they were plague victims. The carbon dates did not fit. They had died almost a century too early.
The English chronicler Matthew Paris described 1258 as a year without a proper summer. Endless rain, ruined harvests, grain rotting in the fields, the poor eating bark, bodies stacked in the streets of London. Chinese imperial records from the Song dynasty describe the same year: frost in summer, failed rice harvests, famine across the empire. Everything agreed. Somewhere in 1257, a volcano had erupted with a force the planet had not seen in millennia, and nobody could find it. In 2013, a French geographer named Franck Lavigneux and his team matched the chemistry of volcanic ash buried on a single Indonesian island with the chemistry in the ice cores. The volcano had a name: Samalas. On the island of Lombok, and it was gone. The pre-eruption mountain rose more than 4,000 meters above sea level. After the eruption, what remained was a caldera 8 kilometers across, filled with a lake. 40 cubic kilometers of rock had been ejected. The plume reached 43 kilometers high, almost 5 times the height of Everest, and delivered around 150 million tons of sulfur dioxide directly into the stratosphere. It was the single largest stratospheric gas release of the last 2,000 years. The reason Samalas cooled both hemispheres is its position. Lombok sits 8 degrees south of the equator. Aerosols injected into the tropical stratosphere ride the equator-to-pole circulation patterns into both halves of the globe. A high-latitude eruption would have cooled only the northern half. Samalas cooled the entire planet by more than a degree Celsius for 2 consecutive summers. Samalas did not cause the Black Death. Nothing that simple happened. But it is the point where the climate record bends. The medieval warm period, the stretch of mild centuries during which European population had grown and agriculture had expanded, ends here. The Little Ice Age begins. The Great Famine of 1315 to 1317, which killed 5 to 10% of Europeans, is part of the same arc. The Black Death of 1347 hit a population already weakened by 90 years of bad weather and poor harvests. The volcano that erased itself left a fingerprint on the next 100 years. The Black Death was just the bill coming due. Same story, 90 years apart. The next item on this list is older than writing, and it is the moment Britain became an island. 8,200 years ago, the floor of the North Atlantic collapsed and a tsunami erased a country. The country has a name: Doggerland. 8,000 years ago, Britain was not an island. The southern half of the North Sea was dry land, a vast plain of forests, river valleys, marshes, and lakes, extending from the east coast of England to the coast of Denmark and the Netherlands. It was the most productive hunting and fishing landscape in northern Europe. Tens of thousands of Mesolithic people lived there. It had been shrinking for 2,000 years. The end of the last ice age had melted the great ice sheets, and global sea levels were rising, slowly by modern standards, but inexorably. By 6,200 BC, Doggerland was already reduced to a long peninsula and a scatter of islands. The end was visible. It would have taken centuries. It took an afternoon. Off the coast of what is now western Norway, the edge of the continental shelf gave way. The slide is named, after the place it occurred, the Storegga Slide. 3,000 cubic kilometers of seafloor, a volume larger than Mount Everest, collapsed into the deep Atlantic in a matter of hours. The largest known submarine landslide of the last 1,000,000 years. The displacement created a tsunami. The wave hit the Norwegian coast at heights of 10 to 20 meters. It crossed the open North Sea
and broke on the eastern coast of Scotland at heights of 3 to 6 meters, depositing a layer of marine sand and shells far inland. We can date the tsunami precisely because that sand layer is preserved in peat bogs in Scotland, in Norway, and in the Faroe Islands. Same date, same chemistry, same event. It hit Doggerland from the north. There would have been no high ground to retreat to. The peninsula that Doggerland had become by 6,200 BC was perhaps 30 meters above sea level at its highest point. The wave swept across most of it.
The Mesolithic communities of Doggerland would have been concentrated along its rivers, lakes, and coasts. The exact death toll is impossible to estimate, but it was substantial. Whole bands disappeared. The North Sea today regularly turns up the residue: antlers, mammoth bones, worked flint tools, harpoons, even fragments of human bone, pulled up from the sea floor in fishing nets. Archaeologists call them Doggerland artifacts. They are pieces of a country that drowned. The Storegga Slide is the moment Britain becomes an island. Not in a single afternoon, but in a final sense. Doggerland never recovered as habitable land. Sea levels continued to rise. Within a few centuries, what had been a peninsula was submerged. The English Channel and the North Sea had won. The modern parallel is not theoretical. There are at least 3 submarine slope failure zones on the planet today that geologists actively monitor for slide potential, including a known unstable structure on La Palma in the Canary Islands that could send a tsunami across the Atlantic if it failed catastrophically. Whether or not La Palma is the next Storegga, the physics is the same. Continental margins are not as stable as they look. The next item on this list takes us further back, to the moment human civilization almost did not begin at all. 12,800 years ago, the planet had just emerged from the last ice age. The climate was warming, forests were spreading, humans were beginning to plant crops. And then, within a single decade, winter came back, and it stayed for 1,200 years. The event is called the Younger Dryas, named for an Arctic flower whose pollen became suddenly common again across Europe, a wildflower that thrives only in cold, treeless conditions. The pollen tells the story before any other record can. Greenland ice cores show what happened. Average temperatures in the North Atlantic dropped by 10 degrees Celsius in less than a decade. In some records, the entire shift happens within a single human lifetime. It is the fastest known climate transition in the last 100,000 years. The world re-entered what was effectively a glacial state. The leading explanation for what triggered it sits in the middle of North America. As the Great Laurentide ice sheet retreated, meltwater pooled along its southern edge. It formed a lake larger than any freshwater lake on Earth today. It has a name, Lake Agassiz, held back by an ice dam. Around 12,800 years ago, the dam broke. An enormous pulse of cold, fresh water emptied into the North Atlantic. The Atlantic's deep water circulation, the conveyor belt that carries warm tropical water northward, slowed dramatically, possibly stopped. The North Atlantic cooled. Europe and North America froze. There are competing hypotheses. A cosmic impact theory was proposed in 2007, arguing a comet airburst triggered the freeze. The evidence for it is contested. The Lake Agassiz hypothesis is the mainstream view, but other meltwater routes, including Arctic pathways, have been proposed. What is not disputed is the fact of the event. The signal in the ice is unmistakable. What happened to the populations on the ground was catastrophic. The Clovis culture, the dominant human population across North America, collapses in the archaeological record at exactly this point. Sites are abandoned. Tool styles change. The continent's megafauna, mammoths, mastodons, giant ground sloths, direwolves, saber-toothed cats, are extinct or in terminal decline by the end of the Younger Dryas. How much of that megafauna extinction was the climate, and how much was hunting pressure from a changing human population is still debated. But the climate signal is real, and the timing is exact. The most surprising consequence of the Younger Dryas may be agriculture itself. In the Levant, a culture archaeologists call the Natufians had been doing something new for centuries, settling permanently next to wild fields of wheat and barley, cutting the grain with stone sickles, grinding it on basalt querns, storing it in pit silos. They were not yet farmers. They did not need to be. The grain came up on its own. When the Younger Dryas hit, the wild grains thinned out. The Natufian villages along the Jordan River shrank or were abandoned. Some groups moved, others stayed and started planting the seeds they used to gather in places where the rains still held. By the time the cold ended, around 11,600 years ago, the Neolithic Revolution was underway. The deliberate cultivation of wheat, barley, and lentils, the foundation of civilization, appears in the archaeological record almost immediately as the climate stabilizes. The Younger Dryas, in other words, may have been the pressure that forced agriculture to be invented at all. The modern parallel is direct. The Atlantic meridional overturning circulation, the conveyor belt that the Younger Dryas shut down, is showing signs of weakening today. Climate models do not predict another Younger Dryas. They do predict that a significant slowdown of the Atlantic conveyor would cool northern Europe substantially while continuing to warm the rest of the planet. We have not seen this state in modern history. The last time it happened, it took 1,200 years to reverse. The next item on this list is the one that did not just rearrange civilization. It almost made sure we never had a civilization to lose. 74,000 years ago, on the island of Sumatra, a supervolcano erupted with a force not seen on Earth in at least 2 million years. Within a few thousand years of the eruption, the entire human population on the planet may have dropped to fewer than 10,000 individuals. The volcano is called Toba. Its caldera is on northern Sumatra in Indonesia. It is 100 kilometers long and 30 kilometers wide. Lake Toba, which fills most of it, is the largest volcanic lake on Earth. When the volcano erupted 74,000 years ago, it ejected approximately 2,800 cubic kilometers of rock. The dense rock equivalent volume, the number after the air and water, are subtracted. For comparison, in the same units, Krakatoa was 12, Samalas was 40, Tambora was 33. Toba was an order of magnitude larger than any eruption in recorded human history. The ash blanketed half the planet. Ash deposits from Toba are still preserved across the Indian subcontinent, 6,000 kilometers from the volcano, in beds that reach tens of centimeters thick at well-studied sites. They sit on the seafloor of the Indian Ocean. They have been recovered from cores in the South China Sea. The eruption darkened the global atmosphere with sulfur aerosols on a scale Samalas did not approach. The volcanic winter that followed lasted, by various reconstructions, between 6 and 10 years. What that did to early humans is contested. Geneticists studying the diversity of modern human DNA in the 1990s identified what looked like a genetic bottleneck, a sharp reduction in the size of the ancestral population somewhere around 70,000 years ago. The estimated minimum size was around 10,000 individuals, possibly fewer. The dating was loose, but it lined up with Toba. The hypothesis became famous. Toba, a volcanic winter near extinction. Some textbooks taught it as fact for decades. In the last 15 years, that simple version has been complicated. Archaeologists have found human and Neanderthal sites that show clear continuity through the Toba layer, populations that locally did not collapse. Genetic dating methods have improved, and the timing of the bottleneck no longer maps perfectly onto the eruption date. Some researchers now argue the Toba bottleneck is real, but smaller than originally claimed, or that it represents a different event. What is not contested is that humans did, at some point in the last 100,000 years, come within a margin of 10,000 individuals from extinction. Every person alive today carries the genetic residue of that bottleneck. There is less genetic diversity in the entire human species than in a single troop of chimpanzees in Central Africa. We are all, in the strictest population genetic sense, the descendants of a small, surviving group. The reason Toba ranks at the top of this list is not what it did. It is what it could do again. There are at least 7 known supervolcano sites on the planet today. Yellowstone in the United States, Long Valley in California, the Phlegrean Fields near Naples, Italy, Taupo in New Zealand, Ira in Japan, 2 more in South America, Toba itself. The recurrence rate for supervolcanic eruptions, the kind that throws over 1,000 cubic kilometers of material into the atmosphere, is somewhere between every 50,000 and every 100,000 years on average. It has been 74,000 years since Toba. We are due. Not in the sense that the next eruption is imminent, geological averages are not schedules, but in the sense that, on a long enough timescale, an eruption of this magnitude is not a hypothetical risk, it is a certainty. A modern supervolcanic eruption would not cause civilizational collapse on day 1. Day 1 would be the survivable part. The volcanic winter would last years. Crops would fail across the planet. Stockpiles would empty in months. There is no plan for it. There is no insurance for it. There is no agriculture that can compensate for 2 consecutive lost growing seasons across all major breadbasket regions. We live on the same planet that almost killed our ancestors 74,000 years ago. The geology has not changed, only the population has. The pattern that runs through every event on this list is the same. Civilization is not as old as it looks. Almost everything we recognize as the human story, agriculture, cities, writing, states, networks, fits inside the last 10,000 years. The list you have just walked through covers about 3/4 of that time. Inside it are at least 10 moments where the entire structure came close to ending. Everything we have built sits on a planet that has not been particularly stable in the past and is not guaranteed to be stable in the future. The atmosphere can be cooled by a single tropical eruption for 2 years. The ocean conveyor can shut off in less than a decade. A pathogen carried in a rat can kill half a continent in 5 years. A flare on the sun can melt the infrastructure of every modern city. None of this is fiction. All of it has happened. Most of it will happen again. The only difference between us and the people who lived through these events is that we know what they did not. We can read the ice, we can read the bones, we can read the chronicle. 7 supervolcanoes, at least 3 submarine landslide zones, a weakening Atlantic conveyor. Yersinia pestis still in the soil across Africa, Asia, and the Americas. The next entry on this list is already loaded. The question is whether we use what we know in time